Hello everyone, we are at Beyond the Formula. Let's see why an inductor opposes change in current. Right, so we have a question here. Can current through an inductor change instantly? So the common misconception is we say yes, it can change, but this is wrong. Current through an inductor cannot change instantly. What happens is inductor fights back. What happens is inductor fights back here. Now we will see how. Suppose I have an inductor. This is an inductor and I connected it to a battery, right? Now what happens here? Current will flow from here I, right? And it will return back. Now you see what happens here. Magnetic field is generated, correct? What does current produce in the coil? Current produces what? Magnetic field, right, in the coil, right? This is the magnetic field produced here, right? Suppose the magnetic field value is B, right? Now you see what happens if I increase or decrease the current, or suppose say I change the value of current, right? So suppose current increases. Suppose current increases. So this will imply magnetic field will increase. Magnetic field will increase. That means there is a change in magnetic field. Suppose B new is greater than B, right? So we have change in magnetic field. We have change in B. And what happens if there is a change in magnetic field? As per Faraday's law, if there is a change in magnetic field, electromagnetic induction will appear, right? And what happens as per Faraday's law? If there is a change in magnetic field, what happens? And EMF is induced, right? So change in magnetic field induces EMF, right? Change in magnetic field induces EMF, correct? So whenever magnetic flux or magnetic field changes, the coil or the nature of the coil generates an EMF. Now the EMF's direction, the positive and negative sign of the EMF is as per Lenz's law, right? As per Lenz's law, which states what? Which states the induced EMF always opposes the change that created it, right? So what Lenz's law states that? It states that the direction or the induced EMF is such that it always opposes the change or the cause by which it is created. Now you see what we have done in the coil. We have increased the current, right? Current was increased. Now if the current was increased, what will inductor say? What will inductor say? Inductor will say, I do not want current to increase. And in another case, if you decrease the current, again the inductor will say, I do not want decrease in the current. Correct? So this is the case, or this is the behavior of an inductor coil. Right? If you switch the situation here, if you decrease the current, magnetic field will decrease. Again, induced EMF will be in such a direction that it will what? It will oppose the cause by which it is decreased. So how then magnetic field was decreased? By decreasing the current. So the inductor will say, I do not want current to decrease. So what we can say here is, if current increases, inductor resist increase. If current decreases, inductor resist decrease. So what we can conclude here? We can conclude that inductor do not oppose the current. Inductor do not oppose current, but opposes change in current. Right? Opposes change in current. Now we will see in the further videos how self-inductor or self-induction happens and the coil creates an EMF inside itself. Right? Thanks.